Ignition sequence start.
Good morning, and welcome to a look at the International Space Station Flight Control Room, where specialists have been overseeing quite a bit of coming and going and change of crew members in space for the past couple of weeks. The last movement of this symphony in orbit is scheduled to begin. After arrival, departure, and another arrival, a second crew departure is set to return the Expedition 65 crew to 7 members and set them up for 5 months on orbit filled with science research, spacewalks, and a few visiting vehicles to keep things interesting.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Isidro Reyna. This week, NASA's SpaceX Crew 2 arrived at the International Space Station. The crew, comprised of NASA astronaut Shane Kimbrough and Megan MacArthur, along with JAXA astronaut Aki Hoshide and ESA astronaut Thomas Pesquet, arrived in orbit to begin a 6-month science mission on the space station. The Crew Dragon spacecraft, named Endeavour, docked autonomously to the forward port of the station's Harmony module on Saturday, April 24th. Supplies to support human research and STEM activities arrived alongside the crew. The astronauts were met with hugs and smiles from their Crew 1 and station teammates. On April 27th, NASA astronaut Shannon Walker handed over station command to Aki Hoshide during a traditional change of command ceremony. Hoshide, Japan's second station commander, will now lead Expedition 65 until October of this year.
Aki, I relinquish command. Congratulations.
And Shannon, I accept the command. Thank you.
The 4 SpaceX Crew 1 astronauts have a new splashdown date after mission managers waved off Wednesday's planned departure due to weather conditions at the landing site. Check NASA TV for the latest on continuous live coverage of the departure and splashdown off the coast of Florida from Michael Hopkins, Victor Glover, Shannon Walker, and Soichi Noguchi on board Crew Dragon Resilience. The new crew has already begun working on numerous science experiments aboard the orbiting laboratory, including the European Space Agency's GRIP and GRASP studies. The GRIP experiment studies the long-duration spaceflight effects on the abilities of human subjects to regulate grip force and upper limbs trajectories when manipulating objects during different kinds of movements, oscillatory movements, rapid discrete movements, and tapping gestures. Data from this experiment may be used to identify potential hazards for astronauts as they move between gravitational environments. These studies could also contribute to the design and control of intelligent haptic interfaces to be used in challenging environments such as deep space, planets and their moons, or asteroids. The Reaching and Grasping, or GRASP investigation, aims to better understand how the central nervous system integrates information from different sensations, such as sight or hearing, encoded in different reference frames in order to coordinate the hand with the visual environment. More specifically, the science team seeks to better understand if and how gravity acts as a reference frame from the control of reach to grasp. Living in space requires adaptation for more than just the astronaut's body. The absence of a traditional up or down requires the brain to adapt to the microgravity environment of spaceflight. This investigation provides further insight into how the body adapts to the microgravity environment. That's Space to Ground this week. Thanks for watching. We'll see you next week.
NASA's SpaceX Crew 2 mission launched from Florida last Friday morning and delivered 4 astronauts from 3 different countries last Saturday. Before they launched, the crew of Endeavour talked about the prospect of getting to fly on a new spaceship, the 6-month space mission they've been preparing for, and the future in space they're helping to build.
My name is Megan MacArthur. I'm the pilot.
Hi, my name is Aki Hoshide, a mission specialist.
My name is Thomas Pesquet, and I'm a mission specialist.
My name is Shane Kimbrough, commander of NASA's SpaceX Crew 2 mission to the International Space Station.
So Crew 2 mission is a mission to the International Space Station. We're going to launch from Florida on a US-developed spacecraft that's called Crew Dragon, and it's going to take us to the space station for 6 months of research, of experiments, scientific experiments, and then we'll come back to Earth.
I love this capsule we're riding on. It was named Endeavour on the Demo 2 flights. It has special meaning for me. I flew on the Space Shuttle Endeavour, so I'm really excited to fly on another spacecraft called Endeavour. It's even more significant, I think, for Megan, because she's going to fly in the same seat that her husband Bob flew in on the same spacecraft. So that's pretty neat.
It's amazing to think that I will be sitting in the same seat that Bob was sitting in when he certified that vehicle the very first time that it launched. I don't think I realized that when I found out that I was going to be assigned to the Crew 2 mission. I didn't realize it was going to be the same vehicle, but that certainly adds a little something special to the mission. So comparing the Crew Dragon with the Space Shuttle training, obviously the vehicles have a lot of differences, even though their goal is the same, to get people into low Earth orbit. And so with the Space Shuttles, built in the 1970s really, we had a lot of switches, like panels and panels of switches. With Crew Dragon, of course, we don't have those panels and panels of switches. We have a very clean wall environment and some large touch screens where we can switch between monitoring different systems. We don't have the same interaction with the vehicle. We can't send as many commands to the Crew Dragon as we could to Space Shuttle, but we have a team of ground controllers that send a lot of those commands and are monitoring in a way that we couldn't do with Space Shuttles back in the day. So it's very interesting to compare the two vehicles and the style of training that's required for the two vehicles.
So we're going to launch from Cape Canaveral, Florida. Falcon 9 rockets. Crew Dragon is our spacecraft on top, and it's going to launch us into a roughly 200 kilometers altitude orbit. And then we're going to catch up with the space station. We're going to do a rendezvous, which is going to fly around the space station in a line and then dock, open the hatches, and then we'll be on board. And that's the main job of the Crew Dragon spacecraft, is to take us from the insertion orbit all the way to the space station in safety.
So once we're on board the International Space Station, there's a lot of things. Main task is doing a lot of different science, whether it's biology, material science, fluid mechanics.
We're just going to do a bunch of nice research and science that's going to benefit all of humanity, or it's going to help us with future exploration. So that's exciting to be part of something that's that grand. We will have some spacewalks planned for our expedition while we're up there, so that'll be some great days out there to go outside.
So on this flight, we have American, French, and Japanese astronauts on board. It's the first time that you have 3 different nationalities on this Crew Dragon. This International Space Station itself is a big collaboration between 15 countries. It is very important to do a lot of international cooperation.
No individual person gets themselves into space, right? It's a huge effort that happens. But it's also true on this global level that we have these big dreams where we look out, to the horizon and this desire to explore the universe around us. And we're always going to be more successful when we work together with our international partners to achieve these incredible dreams.
After 6 months aboard the International Space Station, NASA's SpaceX Crew 1 astronauts are about to come home. The 4 astronauts contributed to hundreds of scientific investigations and technology demonstrations during their mission, valuable scientific research that helps to prepare humans for future space exploration while generating innovations and benefits for people here on Earth. Take a look at some of the scientific milestones accomplished during the Crew 1 mission.
And resilience rises. Not even gravity contains humanity.
We are so excited to be here. We are humbled, and we are excited to be a part of this great expedition and can't wait to get started.
We have several different experiments going on inside of the space station, in racks, in different little facilities like our life sciences glove box that we use for biological and life sciences. But we also have experiments that are run on us.
Space to ground 3 for Shannon. We're watching the flame do its thing. We have 3 very mesmerized PIs.
Yep, and 1 mesmerized crew member here.
All right, are you ready for this? What do you think of that?
I see worms!
Right there.
Wow! That
the plant will grow in this direction, meaning we'll put some light on top of it, and we'll see how it grows for the next 30 days.
Again, Shannon, you struck it rich for us. That was great. That's the primary objective right there. Yes, we got double thumbs up down here, too.
Station Spaceground 2. Signals capture is complete. Welcome to ISS. SS Kathleen Johnson.
Thanks, Oliver. You're a man. That was awesome. Thank you so much.
We develop technologies and ways of using those technologies, healthcare and medical technologies that are ways to improve life on Earth. But even more important than that, I believe, space has a way of universally inspiring people. Making folks want to do very challenging things to the best of their ability is what I think human space exploration does most for humankind. And so the human aspect of human space exploration is always going to be very important, I think, for decades to come.
The astronauts and cosmonauts on the International Space Station work on science research in a wide range of disciplines, while the station itself also serves as a platform for instruments that study what goes on below the station, including colorful bursts of energy that happen above thunderstorms. Now, these instruments that help scientists study transient luminous events may prove useful to our better understanding of our climate, our weather, and the behavior of storms.
If you're on the ground during a thunderstorm, you might witness a spectacular show of lightning. But if you're observing that same thunderstorm from the vantage point of the International Space Station, you might see a bolt of energy shooting up from the clouds, and it might be red, or blue, or even green. These particle outbursts are like nothing seen from the ground and may prove useful to predict weather outcomes more precisely, better understand changes to our climate, and increase the safety of planes and ships approaching dangerous storms. They have names that sound like they were taken from a fantasy novel: Blue Jet, Gigantic Jet, Red Sprite, Halos, and Elves. But all belong to a more scientific-sounding family, transient luminous events, or TLEs. Flashes and glows that appear above storms that are results of activity occurring in and below those storms. Dr. Timothy Lang is a lead research aerospace technologist at NASA's Marshall Space Flight Center. He explains how two key observational instruments aboard the orbiting laboratory are helping scientists better understand these colorful bursts of energy. We use the Lightning Imaging Sensor, or LISS, to map lightning in 2 dimensions with global scale coverage. It shows us where the thunderstorms are taking place, and how powerful each one is based on the size of its lightning flashes. So it's akin to a macro camera. Another instrument, the Atmosphere Space Interactions Monitor, or ASIM, is operated by the European Space Agency. ASIM gives us very fine detail of a TLE's flash. In essence, it's akin to a microcamera. Torsten Newbert, ASIM principal investigator at Denmark's National Space Institute, adds that ASIM and LISS make observations in different ranges of the color spectrum, allowing for different views of these particle events. So LISS is macro, ASIM is micro, and together they provide a powerful combination for exploring lightning and TLEs. The space station offers an excellent vantage point to scientists studying TLEs. At about 250 miles up, it is much closer to these phenomena than a geosynchronous satellite. Further, the station's orbit allows for coverage of storms worldwide. All this allows LISS and ASIM to produce a unique space-based data set of thunderstorms and their effects, which in turn helps support other observational instruments. LISS, for example, has been used to calibrate instruments and verify data for the geostationary lightning mapper on NASA and NOAA's GOES satellites. and will also support the Lightning imager on the European satellite Meteosat 3rd generation. This support helps make data produced by these sensors the highest quality for serving the public. From the space station, LIS can provide Lightning data in near real time for the benefit of those on Earth. It can report lightning nearing dry areas of forests prone to wildfires. It's integrated into the NOAA Aviation Weather Center's operations, which provide weather forecasts and warnings to the U.S. and international aviation and maritime communities. And over time, it can map data points to help scientists observe changes to our climate over broad tracts of land and sea. In short, studying lightning and its effects both below and above the clouds can have a big impact on how we view our planet. Doing so from the International Space Station is improving that view in ways that couldn't be accomplished anywhere else. For more electrifying information about the International Space Station, go to www.nasa.gov/ISS-science. To discover more about the space on, around, and beyond our planet, visit science.nasa.gov.
Astronauts who do science on the International Space Station also spend some of their time helping explain scientific concepts to students on Earth who are studying the STEM fields of science, technology, engineering, and math. In this demonstration video, one-time station commander Sonny Williams guides us as astronauts Mark Vande Hei and Jeff Williams make use of the weightless environment to demonstrate Newton's first law of motion.
Hi, I'm Sonny Williams, and I'm an astronaut who's lived and worked aboard the International Space Station, an amazing research laboratory that's orbiting the Earth about 250 miles above us. While we're at the space station, we astronauts live and work in a microgravity environment. Do you think the laws of physics will hold up in the space station while experiencing microgravity? Let's check with NASA astronaut Mark Vande Hei on the International Space Station to find out.
Newton's first law of motion says an object at rest tends to stay at rest unless acted on by an outside force. Also, an object in motion tends to stay in motion unless acted on by an outside force, like my finger.
Let's look at this from another angle. Over time, the International Space Station slows down from experiencing a very small amount of drag, or force, from a tiny amount of atomic oxygen in space. This is like the force you feel from the air if you stick your hand out of a moving car. Because of this, the space station does what we call a reboost. A reboost uses rocket engines to put a force on the space station. This allows it to speed up just a little to remain in orbit around the Earth. Let's join NASA astronaut Jeff Williams to check out what happens to the objects inside the space station when it begins.
Now, the way I'm going to demonstrate the acceleration that comes during the reboost is by using this camera. 800 millimeter lens, so it's pretty massive actually. And you can see I can float it here, and there's no reboost going on right now, so the camera's not going to go anywhere. It's just going to slowly drift due to the ventilation, or if I put any velocity into it, it'll drift out of the scene. But I'm going to try to hold it here steady, and you can see that it stays very steady. There's my camera. I'm setting it up for ignition. There it goes. It actually came a little bit early. Now watch the camera accelerate toward you. There it goes. I'm going to reach out and grab it and bring it back in the view here. And I'm holding it. I'm actually feeling the acceleration. I'm going to let go again. And here it goes. It's going to take off. I'll try not to let it hit you. just gonna miss you. Yeah, I'm gonna let go now. And here I go, drifting back toward you again. So the acceleration applies to me too. Reached our 2.7 meters per second that we desired, and now if I let go of the camera, it's not going anywhere, so the burn is over. Reboost complete. We'll stay in orbit for a little while longer.
Can you use Newton's first law to explain why the camera began moving without an astronaut putting a force directly on it? I'm going to send you back to class so you can start to investigate this with the Classroom Connection found at nasa.gov/demonstrations. Thanks for exploring a little physics on the space station with us today. See you again soon.
Can you imagine what the Earth looks like from 250 miles up? Well, now you don't have to. International Space Station astronauts wearing small high-definition video cameras during recent spacewalks have delivered the evidence, and it's gorgeous. Have a look for yourself at imagery captured during 4 different spacewalks between July 2020 and March of this year. If you want another look at any of the stories you saw today, you can always find them on YouTube and Facebook, where you'll also find lots of other great features on a wide variety of NASA topics, so be sure to look around. If you're looking for good conversation about human spaceflight, check out Houston, We Have a Podcast, our weekly show talking to folks involved in all areas of space exploration. Today, Gary Jordan is hosting a panel discussion on the commercialization of space, with a focus on the role of the International Space Station in encouraging private companies to become part of the space economy. Go to nasa.gov/podcasts for this week's episode and all our previous episodes, and the full library of all the NASA podcasts, which are also on Apple Podcasts, Google Podcasts, and SoundCloud.